Hi everyone and welcome back to PrepFusion. So in this video we will solve this particular question that someone gave in our WhatsApp doubt solving group. A lot of people were asking this query and I did initially solve this query. I did upload the video, but the problem there was I did not solve it on myself. So I directly started recording and directly solved there. That was a big mistake from my end. I should have solved before turning on the recording, and I made quite a few mess ups there because like I don't know what happened today. So that's why I'm re-recording the first part. The second part is already there. I will put the link in the comments below where I will discuss regarding the second case. I will discuss for the first case in this video, right? So like we have a circuit here, RCC is there, the input is pulse, the time period of the input is capital T. We have to plot the output voltage for two cases. I will talk about first case in this particular video, and the part 2 will talk about the second case, right? So case 1, this one, right, where my time period is much greater than RC. So RC we know is somewhat related with the time constant, right? So obviously if you don't know basics of transient, please go and watch that video, then only you will understand it. Also, if you want to learn more about pulse response, you can, okay, where is that video? Yeah, you can watch this video where I have discussed about pulse input in details, right? So I will not go into each and everything here. So yeah, let's discuss. So I'll talk about the first case. So for this first case, they're comparing some sort of time constant. Let me first find out the time constant of the circuit. Is this first order circuit? Yes, this is. If I assume a voltage here, VC1, then I can write this voltage across VC2 in terms of the input and the VC1 voltage, right? We can do this, right? So this is a first order circuit. That is first thing. How do I find out the time constant? Simply nullify the input. If I nullify the input will be shorted. Then this R is there, this C is there, this C is there, right? And then I have output. So these two capacitors are in parallel, right? So A and B, if I assume this B point is same because both are grounded. So across A and B, I have two capacitors in parallel. So this will be 2C and R is also there. So R equivalent is R, C equivalent is 2C. So your time constant is actually 2CR. Now in this situation, they're telling you that your time period is much greater than R. So let's assume one thing, right? Time period is, let's assume it is 4 millisecond and your RC is 4 microsecond. So if time period is 4 millisecond, I want to do one more comparison. 2 millisecond. What is 2 millisecond? 2 millisecond is capital T by 2. Why? I will explain in a bit. 2 millisecond must be much greater than what? The time constant, or I can say what is 4 tau, because 4 tau is the time or duration that a circuit takes to reach steady state, right? So if RC is 4 microsecond, 4 tau would be 2 RC would be tau. So 2 tau is equals to 8 microsecond and 4 tau would be 32 microsecond. So does this relation still holds true that 2 milliseconds much greater than 32 microsecond? Yes. So capital T by 2 is still much greater than 4 tau. Why capital T by 2 is important? Because if you see, my input is not changing for capital T by 2 half time period, right? And my circuit will only take 32 microseconds to reach steady state. So as if I'm connecting -5, as if the input is already -5 forever and circuit will reach steady state in that duration. And then again, once the next 5 volts comes, then the circuit will become circuit again. Then this circuit will observe that as if this 5 volt is always there because it will reach steady state. So let us now draw the circuit at t equals to 0. If I draw the circuit at t equal to 0, assuming initially the capacitors were not energized. If the capacitors were not energized, that means I can replace the capacitors with short circuit, and here I have applied a voltage of -5. If you see, initially the voltage is -5, right? So initially if the voltage is -5, then obviously both are acting as a short circuit. So an impulse current will flow through all of them. So both of them will be charged to minus 2.5, right? So both of them at t equal to 0 plus will be charged to minus 2.5. Why? Because impulse current will flow and they have to be instantly charged because both of them are C. So if you don't understand how both of them got charged to minus 2.5, you have to go and watch the transient videos. I will not be able to explain here, right? Impulse current, same impulse current is flowing through all of them, both the capacitors, so it will be minus 2.5. Okay, after this what will happen? After this is at t equal to 0, right? At now I see that this particular resistor will draw some current because across it I have a 2.5 volts. So it will draw some current, due to which this capacitor will discharge, and this capacitor will discharge through this resistor, and this capacitor will charge further, right? Because the current will flow in this direction. What will happen? Current will flow in this direction and in this direction. So from this capacitor, the current is going out from the positive terminal, but for this capacitor, the current is incoming to the positive terminal. So this voltage will try to go towards, VO will try to go towards -5, right? VO will try to go towards -5, and this VC1 will try to go towards 0. This is a very standard circuit, and I have solved this circuit in my transient videos in step response. So if you don't understand step response, go and watch that video. So what will happen if I plot the waveform? Instantly it will go to -2.5 volt, then it will try to go to -5, right? And it will reach -5 very quickly, because I have enough time, right? I need only 32 microseconds to reach -5, but the input of -5 is present for 2 milliseconds. So I have more than enough time to remain at -5. Now I am at -5. Now at t equals to capital T by 2 plus, right? T equals to capital T by 2 plus, what will happen? Suddenly this input voltage will change from -5 to +5, right? So this capacitor has 0 voltage, and this capacitor we know has -5 volt. Now there is again a problem. Again there will be a KVL violation. Again there will be a KVL violation, right? So what will happen? Both of these capacitors will provide very low impedance path. Both of these capacitors will provide very low impedance path, because there is a KVL violation. Again, if you see, basically this will be 10 is equals to 0, which is not possible, right? If you apply KVL, 10 equals to 0, not possible. So huge impulse current will flow, which will energize both the capacitors, which will charge both the capacitors. So that impulse current will flow through this capacitor and this capacitor, same impulse current is flowing. If same impulse current is flowing, basically both the capacitors are getting the same amount of charge, because same current is flowing. So charge is same, and I know that the what is this change in charge is same, right? And I know this capacitor has capacitance C, this capacitor also has capacitance C. So this will be, let's say, both delta Q1 and delta Q2 are same, right? Charges are same. So delta V1 equals to C delta V2, right? So now what will happen? That delta V1 will be equals to delta V2. Basically the change in voltage will be same. I have taught this concept in my switch capacitor videos. Change in voltage will be same, right? uh, now the change in voltage will be same, but what is the value of the change in voltage? How do I calculate the change in voltage? So this is one equation. Other equation is, so if the voltage will change, the voltage, what is delta V2? Delta V2 is basically nothing but initial voltage. Initial voltage is -5 minus the final voltage. I don't know what is the final voltage. Let's say V2 final. I'm talking about this capacitor V2, minus the initial voltage. Initial voltage is -5 here, right? My polarity is like this, right? This all these I have taught in the switch capacitors concept video, right? And delta V1 is basically final voltage minus initial voltage was how much? 0, right? Just before T by 2 the voltage was 0. So this is V1F final, this is V2F plus 5, right? Now both of these have to be same. One more equation I know, that at t equals to capital T by 2 plus KVL has to be satisfied. So if I apply KVL here, this will be 5 will be equals to this final voltage across this capacitor V1F plus final voltage across this capacitor V2F, right? From these I get two equations. One equation is these two has to be equal, right? Because delta V1 will be equals to delta V2. So V1F will be equals to V2F plus 5. So V1F minus V2F equals to 5, right? now I can add these two equations. If I add these two equations, I get 2v1f equals to 10. So v1f becomes 5 and v2f becomes 0. So this output voltage, right, at t equals to 0 plus will become 0, and this will become 5. This will be instantly charged to 5, and it makes sense because the same impulse current is flowing. Both of them have to be charged by same amount. So, and the KVL has to be satisfied. All these three things have to be satisfied at the same time. So this will be 5 volts, right? If you do the calculation, this will be 5 volts. So what is happening to the output voltage? The output voltage is suddenly jumping from -5 to 0. Why? Because impulse current is flowing. Then again, at steady state, what will happen? Again, the voltage across this capacitor is 5 volts, right? If the voltage across this capacitor is 5 volt, this will again try to discharge. But right now in the other direction, in this direction, right? So this will discharge. So the voltage will reduce. Obviously, again, this capacitor voltage will again increase from 0 to +5. So this will increase now exponentially because right now it is stable, KVL is satisfied, right? So it will increase exponentially from 0 to +5 very quickly. Now, what will happen at capital T plus? Again, at capital T plus, something different will happen. What will happen this time? This is my VO of T, right? Capital T plus, if you observe something that right now, if I draw just before T equals to capital T minus, right? So this capacitor will again be 0 volts, steady state, right? This capacitor will have voltage of plus minus 5 volt. And again, if you observe, I'm applying reverse voltage, right? -5. Again, there is a difference. So what will happen? Again, this voltage will go from +5 to 0, and this voltage will go from 0 volt to 5 voltage in this direction, in the opposite direction, right? Same concept, charge conservation, same impulse current, KVL violation, same thing. So what will happen to the curve? That again, this will jump from 5 to 0. So this time is capital T by 2. This time is capital T, right? And again, this will, what will happen? The moment it gets charged to 5 volt, again it will discharge through this resistor, and the other potential and the other capacitor will be charged to 5 volt. So it will be like this. So this is actually a pretty good question, right? And this will now repeat basically, although this is not looking like symmetrical. Okay, so I made a mistake previously, so I had to cut the video. So the voltage waveform would be something like this, right? Again, it will jump from +5 to 0, and again exponential charging, and like this. This will be the repeated pattern basically, right? So this is capital T, this is 3T by 2, this is 2T, right? And this will be repeated. So voltage also will be kind of a square wave from -5 to 5. Only in the first cycle I will have a jump of 2.5 because initially both the capacitors had 0 voltage. That's why. But after this, the things will just repeat, right? Things will just repeat. So yeah, that was a solution for the first part. If you want to understand the next part, I have provided the link. You can go and watch that video for the next part of the video.